All right, guys, so today we're learning 8.4, which is the cross product. Please remember the other day I talked about the difference between dot product and cross product just a little bit. I'm going to make more mention of them later, but today we are learning something called the cross product. Now, as we are working through the cross product, there is a mini other little lesson I have to have at the beginning of this because of the way that we solve this and what we do. Now, if you remember, a vector represents anything that's going in a direction. It does not mean it needs to start at the origin, right? It doesn't have to start in this bottom corner and be going that way. It could randomly start here. It could randomly start anywhere. And so when we say a vector has 6, 4 as its components, it just means it goes 6 to the right and 4 up. It does not necessarily mean it starts at 0, 0 and goes over 6 and up 4. It could start at any random point and it just moves 6 to the right and 4 up. And so because of that, we have these things called unit vectors, okay? Unit vectors represent one unit. Obviously, that's why we say unit, kind of like the unit circle was a radius of 1. And these vectors represent a direction, kind of like when we write it in that order. But just so you know, I, written as a vector, would be 1 unit in the x direction. J would be 1 unit in the y direction. Sorry guys, when I was first writing that, I kind of rewrote the x there. And then K is 1 unit in the z direction. Remember x, y, z, x still goes left and right, y still goes up and down, but z would sort of come forward or towards the graph, towards the computer or away from the computer for you. So those are our 3 unit vectors. And so previously, we would write vector A like 4, 6. But because of unit vectors, if I would want to, I could write A as 4i plus 6j, because this is the first component, therefore it is my x direction. This is my second component, therefore it is my y direction. Again, I is x, j is y. There is no k here, so we don't have to write plus 0k, just like normal, we don't have to write that there. But we could if we would want to. And so everything we've been doing this chapter, we could have been using unit vectors. We could have been using unit vectors. So you know how a few days ago when we did A plus B, I am meaning A plus B right now. When we did A plus B, we would just do 4 plus a negative 2 and we would get 2, but we would have them in these vector brackets instead. If we would want to, we could pretend that A is 4i plus 6j and B is negative 2i plus 8j. So when we do this, we would combine our I components, combine our j components just like we would before. So 4 and minus 2 is 2, and you keep that I on there to say that's still in the I direction, and 14j. The reason I didn't bring it up till today because it really kind of follows everything else as well, and it actually is needed for today. So just as a reminder, today we're working on something called the cross product. Now, 2 days ago we did something, remember I said it's very important in vector math to know this. In regular math, they're the same. This right here means the dot product. I should probably put a cross through that, or, well, not a cross, but like an X through that, because this is not what we're doing today. Today on the homework, you will not see dots there, okay? You will always see this A cross B. So a couple things here that I would like to tell you about. First of all, when we are finding the cross product, and I'm going to tell you in a second exactly what the cross product is, but because of the cross product, we really have to have the vector with 3 components. So just a second ago when I had A being 4, 6, it would be 4, 6, 0. You would just add that 0 there yourself. The 0 always comes third because if we have 2 components, it means it's in the x and the y direction, and there is no z direction. So you can give it a component of 0. So you have to have 3 components. So if there's only 2, please make the third one 0. And then I'm going to talk a little bit about exactly what is the cross product and what can we do to make sure we found the right cross product. Okay, so I have a few pens here to kind of help me out. When we have 2 vectors, of course they have a size and direction, and maybe the pen cap is what direction this one is going in, okay? And so the pen cap on this one. Now, if we were to have 2 vectors that would cross, that's why this is called the cross product. there should be a third vector that I can find, and this is the tricky part. If I try to hold these pens together, there should be a third vector that would be perpendicular and sort of make like a perfect corner of a room or something like that. But here's the deal. Do you notice as I'm moving these around, this marker that I'm currently using as the third vector also sort of has to change directions and move? Okay? And I know this sounds kind of funny, but it kind of depends if this one is first and this one is second, because you got to do it in a different order. It kind of gives it a little bit of a different direction. It is a little bit of it, but order makes a difference when we are doing cross product. So don't think A cross B is going to be the same thing as B cross A, and actually I'm going to make sure to do that and cover that in the first couple examples, okay? So the main thing is that the answer to a cross product is another vector. The other day when we did the dot product, I said, guys, some number is your answer. That's it. Some number is your answer. Our answer today is going to be another vector. And so our vector will always have an I, J, and K component. And the process of finding the cross product is actually pretty easy. The first one I'm pretty much going to do completely for you so that you realize kind of where things come from and how to do it. Obviously, it's the first time, so I need to help you out a little bit. Second one, I'm going to help lead you through a little bit more, but hopefully as I'm doing it, you're able to fill in a little bit more by yourself. And just remember that the cross product is supposed to be an item that is perpendicular to the first two vectors that you were given. So here's what you're going to do, okay? You are going to make it into a matrix, okay? You're going to write a matrix, and I'll tell you how to make that matrix. You're going to kind of decrease the size of the matrix so that you can find 3 different determinants. But then remember, our answer is a vector, so we have to write our vector answer. And again, if you follow along with me in the next few minutes here, it's going to be really pretty easy to figure it out, okay? So write it as a matrix, and again, in my steps, I show you exactly what to do. Decrease the size, find 3 determinants, and your answer should already sort of be in vector form, all right? So here's the first example we're going to do, and the first example we're going to do A cross B, and please remember that order does make a difference, all right? So we are going to originally write a 3x3 matrix. It makes sense that it's 3x3 because if you look at this, there are 3 components, I, J, and K, and each vector has 3 numbers. So the top row of your 3x3 matrix, you are going to write every single time this is the case. You are going to write your units vectors. So always, always, always on today's homework, you're going to have I, J, K across the top. The second one, you are going to write the coefficients only for the first matrix that is, first vector that is listed. Not necessarily always going to be A, but when you read A cross B, if A is written first, you write A here. If B was written first, you would write B here. If it was D cross E, you would write D here. So we're going to fill this in a minute, and you can fill yours in. I'm going to use a little bit more space just because this one I want to explain a few things and write it. I have another piece of paper to do the work on. We would write 3, 8, -2 straight across, and that kind of makes sense too because your I component is 3, your J component is 8, your K component is -2, which means then in the bottom row of your 3x3, you're going to write your coefficients for B. So you would write 5, -3, 3. All right, so here is my piece of paper, and here is where I'm going to do my work. Now, like I said, we're going to decrease it. And as I do this, I'm going to kind of explain what's happening, and I'm going to explain what you do and how you do it and why we decrease it, and then it makes it kind of easy for us because we've already learned about matrices. So you're always going to pretend to cross out the top row because I don't want to write a whole lot of stuff. I'm always going to use these pens. So you're going to always cross out the top row. So in just a minute, I'm going to pick up that blue pen again, and I'm going to cross out the top row. But slowly, to decrease your size, remember we want a square matrix. I'm going to cross out one row at a time, or pretend one row is not there. Now, do you see how when I do this and cross out this first row, you see a new 2x2 matrix? the 2 by 2 matrix you see looks very much like a 2 by 2 matrix. 8, -2, -3, 3. We are going to write that down in just a minute. But if you notice, do you see how I doubled up and I covered up this twice? So since this comes from crossing out both parts of I, because you would cross out this way of I and this way of I, and I kind of got the double whammy, you are going to write an I with that matrix we saw of 8, -2, -3, 3. Sorry guys, I wrote this just in the pen, not the permanent marker, so I'll hold it a little bit closer for a second. This is going to be the first thing you write down, okay? And once again, that comes because we crossed out the top, so we don't even see I, J, and K. But then I cross out this side, so I don't see that 3 and 5, and I see that matrix right there of 8, -2, -3, 3. But because I crossed out I twice, that's why I wrote I there. So we're going to do the same thing. We're always going to cross out that top row, but I'm just going to move, right? That blue pen is still crossing out the top row. The other pen, my black pen, I'm going to just move over. So originally I had it crossing out the first row. This is the one that's a little bit tricky because it's hard to see this 2 by 2 because of the space in the middle. But I'm going to use the black pen to cross out here. What unit vector has been crossed out twice? And what 2 by 2 matrix do you see? So at the bottom here, the 2 by 2 matrix, I hope you saw, even though it was kind of confusing because that space in the middle, how many people see 3, -2, 5, 3? So that's the matrix I'm going to write down. 3, -2, 5, 3. And the unit vector I crossed out twice was J. All right, if I follow that process, and some of you are maybe already figuring this out and maybe already wrote it down, I would cross out the top row still, but this third column. And so the thing I crossed out twice was K, but I see 3, 8, 5, -3. So I see 3, 8, 5, -3. And the thing I crossed out twice was K. Now this next part usually is a part that brings up a few questions with people, and I know since I wrote in permanent marker up here and pen down here. So here is the part that's weird. You're sort of going to combine these, but this is a weird thing. And again, remember, we could have a bigger matrix. Like if you were working with vector math and matrix math, we could have like a 7 by 7 matrix. We could have a 10 by 10 matrix. And this is how math always works, okay? You sort of get a pattern and develop a pattern. And remember when we used to, when we find determinants and we go down, we keep our answer positive, but when we go up, the answer is, when we go down, we keep our sign the same. Excuse me, I think I was thinking ahead there. So when we multiplied down our matrix, our value stayed the same, but when we multiplied up, we would switch it up, okay? Because of how this is, we still have to kind of have that change, keep change, keep change, keep change. And because of the way we do this, our first answer is going to keep the sign of whatever we find. But here's kind of the weird thing. We would sort of have whatever we have here, but here I'm going to write a minus sign to say, hey, I got to flip the sign of that. I don't know what it is right now, but because I write that negative there, it's going to end up flipping the sign of whatever I get. Right here, I don't know what sign I have, but if I write a plus, it means I'm going to keep the same sign of whatever is there. Again, if I had a 4 by 4, the next one would be a minus. I would flip the sign of the next one. So it's kind of like keep, change, keep, change, keep, change, and that's the pattern you would do. Now, if I zoom in a little bit here, how many people see this very small matrix right here? And guys, even though I barely left room, I have plenty of room to do the work at the bottom. How many people see 8 times 3? Because you have this 2 by 2, we're now going to find the determinant, like I said. So we're going to do 8 times 3. All right, and sometimes that was the one I get flipped around in my head. So 8 times 3 is 24. And so 24 keeps the same sign. 24, but then if I multiply up, I have 3 times 2, which is 6. But since I get a positive 6, I do have to subtract it. So I'm going to take 24 minus 6. How many people get 24 minus 6? Hopefully you do. If not, click over and ask me questions on the Google Meet. And so you get 18. It is a positive 18. Remember, because this is my first one, I just keep it as 18i. 18i. All right. Next, I'm going to find the determinant of this 2 by 2 right here. So I have 3 times 3, which is 9. If I multiply up, I get 10 times negative 2, but remember I'm supposed to switch the sign of that. So I'm going to get plus 10. 9 plus 10 is 19. 19j, but please remember that middle one, because of keep, change, it was a 19. I got to make it minus 19. And then over here, I have my 2 by 2. So I'm going to do 3 times negative 3, which is negative 9. 5 times 8, because that's 40, but I'm going up. I got to subtract 40. Negative 9 minus 40 is negative 49. And the k would be attached to that. And because of this plus, I keep the sign that I had, so that is 49. So I'm going to write my answer right here. Guys, remember, right now I did A cross B. A cross B would be 18I minus 19J minus 49K. All right? And yes, sometimes some of the numbers are relatively the same. The other number is different. All right, so just real quick, I'm going to remind you of a few things, and then we're going to check. Here's the deal. Sometimes when people are doing stuff, they're like, man, that 49 is really big. That 49 is really big. Maybe I did something wrong. So how checking helps? Checking goes real quick, okay? And so I got to tell you something. Do you remember when I was holding up these pens and I said the cross product is these two pens and it's perpendicular? So here's the deal. The blue pen and the marker would be perpendicular. The black pen and the marker would be perpendicular. Yes, are the blue pen and the black pen perpendicular to each other? Not necessarily. So the two originals I know nothing about, but the marker should be perpendicular to both of these. And so what you're going to do to check your answer is I am going to write back in our normal form, I am going to write my answer twice. So do you see how I wrote my answer twice in our vector components like that? Underneath one of them, I am going to write A. Underneath the other one, I am going to write B. And what I am going to do now, if these are actually perpendicular, if I find the dot product, which is just quick, simple multiplication and addition, I should get 0 for both of these. So I'm going to take 18 times 3. Everybody see how right here I have 18 and 3? Okay. 18 times 3 is a positive 54. Next I have 19 times 8. That's minus 152. Next, I have 49 times 2, but they're both negative, so that's going to be a positive 98. And so would you agree I have right there 54 minus 152 plus 98. 54 minus 52, plus 98 equals 0. So when I found the dot product of these two, it does show that they're perpendicular. Let's try this other one. 18 times 5 is 90. Negative 19 times negative 3, those are both negative, so that's going to be a positive 57. But then I have 49 times 3, one of them is negative, so that gives me negative 147. So I have 90 plus 57 minus 147, and what do you know? Also equals 0. So because the cross product is perpendicular to both, you can check your work right there. Okay? So guys, I know this video took a little bit longer. I know we're almost to 19-ish, 20 minutes. But I want to tell you that order matters. And so what I would like to do is I already went back and rewrote B, but I wrote B first, and then I wrote A. You are now going to find the cross product of B cross A. Okay? I would like you to work on that by yourself. Remember, a few minutes ago, if I hold this up close, our matrix looked like this. Now our matrix looks like this. Our first answer was A cross B equals 18I minus 19J minus 49K. Your job is to find B cross A. I already have the matrix set up for you. I maybe should have had you do that by yourself. But guys, all you're going to do is that over and over and over again. So I'm going to have you click back over to the Google Meet. If you notice, if you're watching the YouTube video, you're pretty much at the end because you're at the end of the video. When you come back to the Google Meet, you're going to tell me the answer to this. If you need more examples, I have more examples that we can go through, of course, all the time. But some of you are going to be like, oh, I get this. I understand how to do it, especially if you tell me A cross B. We found A cross B together. If you tell me B cross A and it makes sense to you and you're good to go. If not, I always can get more examples and we can work through them on Google Meet with you asking questions, and it's more of the live teaching. So I'm there the whole time. Come back to the Google Meet, of course, to tell me what B cross A is. But if you come back and it's making sense, the homework should be posted or will be posted by the time you get there. And yeah. It's Friday, so have a good weekend. If after I talk to you on the Google Meet and stuff like that, I hope you have a good weekend and I hope things are going well. It's May. Seniors, you're almost there. I know it's not fun, and I apologize for that. I feel so bad for you guys, but keep on going. You guys are doing great work. Keep it up. Keep working hard. You guys will be fine. Okay? Miss you guys. Bye.